Hi, this is John Bleiler. I'm the Chief Content Officer for Extension Media, Editor-in-Chief of Chip Design Magazine. Today I'm with Zhihong Liu, who is the Executive Chairman of ProPlus. Zhihong, chips today are complex. They are continuing to be complex. They're also continuing to be smaller, so we're talking down at the nanoscale. It used to be that you could do corner analysis, a few corners, at the higher nodes, higher geometries, and you were okay. But now engineers are going to have to do statistical analysis, and that's a new twist. Do you have some thoughts on that?
Sure. As the technology going down to nanometer range, the process variation become more and more important. Everybody know that, so the corner become more and more. So people start to look into why only corners, and you need to look into the problem statistically. In order to do the analysis statistically or design your chip statistically, really you need to have a tool that really can boost the productivity. Otherwise, statistical analysis will cost a lot of design time, right? So I think the key is how you can do your design efficiently, but also can do it statistically. That's the challenge, time and the cost. Where people look into how we can overcome the design challenge, not only by counting on the fab to give us a stable process, but also from my design to design a better product that's more tolerable, more robust for process variation.
So how is that done? I mean, as an engineer, it'd be great to have a button that I could just press, but with statistical analysis, well, you need to understand some things. How are you reaching the designers with that?
A designer used to count on the process, the fab, to really stabilize their design, right? So that you can get so-called DFM issues, and also now people more talk about the DFI, design for yield. That means the designer need to consider how to make their design more robust to the process variation, which is natural things. You have to have it, right? So designer usually just do one design and then run all kind of corners. Now, for key components of their design, for example, the SRAM cell, typically, you need to consider the variation, not only the process corner, but also the relative variation, the so-called random process variation. Means like, for example, your transistor pairs, even they are manufactured at the same time with the same process, but they can still be different. How you're going to take on that? You need to have a tool. Efficiently do that. And the people has been working on that for as long as the product has been there, right? The problem, however, is now you need to do more. You need to do more sophisticatedly, and that will cost more time.